Hello everyone, Mr. Minnick's my name, math is my game. Today in my Algebra 2 classes, we're talking about the last piece of the puzzle for factoring for now. Yeah, it's about time. It's been 5 days of nothing but factoring notes. I know they can't wait to be done with factoring. But guess what? When we get to chapter 4, section 6, we're going to be factoring again. When we get to chapter 5, sections 2, 3, 4, and 5, we're going to be factoring again. And then we're going to go to chapter 8. And in chapter 8, sections 3 and 4, we're going to be factoring again. So we're not done with it by a long stretch, but by a long shot. But here we are. We're factoring special cases. I'm going to bring out my chevron. You guys know what a chevron is, right? I'm going to have 2 of these. I'll make this one red, and I'll make another one, and I'll make it blue, and I'm going to have 2 chevrons like this. So I'll make this one blue. There we go. So there's 2 special cases of factoring that we're going to look at today. There's actually more. When we get to chapter 5, we're going to look at a couple more, but for today, we're going to look at 2 special cases of factoring. I'm a big visual kind of guy. I like to have things that help memorize stuff. You know, like keep piling cards on 5 giant stacks, like SOHCAHTOA, like Roy G. Biv. Anyway, for this visual thing, what we're going to have is we're going to have something called a DOTS. Maybe you know what that acronym stands for, maybe you don't. But what it's going to look like, this is the general pattern. It's going to have 2 terms. So that's what the T stands for, 2. It's going to have 2 terms in it. And we're going to be taking the difference. That means we're going to be subtracting. And the O stands for of. Some people call it just a DTS. They think of is irrelevant, whatever. And then the S. In math class, what do you think S could stand for? Sums, systems. So when we talk about quadratics, we have some x value and we're squaring it, right? So it's going to be squares. Squares. Okay? So this is going to be a squared minus b squared. What you need to know about a squared and b squared is they're numbers. Sometimes they have variables in them, but they're going to be numbers that are perfect squares. So I think it'd be a wise move to talk about what perfect squares are and to list them out. My second period class already had this lesson today, and I told them that I expect them to memorize these 20 perfect squares. What that means, what I'm insinuating, what I'm implying is next week I'm probably going to give you a timed quiz where you're going to have to regurgitate these without your notes, without a calculator. 1 squared, 2 squared, whoop, I said squared, 3 squared, 4 squared, 5 squared, 6 squared. We're going to keep on trucking because we're a trucker like that. 7 squared, 8 squared, 9 squared, 10 squared. Everybody knows those. Well, not everybody. Some people don't. So, of course, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is 100. I'll bet that half of the world's population could rattle those off. I'll bet. The adult population in the world. That reminds me, did you guys hear about the little kid that was in school? The little kid said to his teacher, Mrs. Smith, my mommy's having babies. She's having twins. And the teacher says, well, do you know what she's having? She says, yeah, she's having twins. Well, I mean, do you know what she's having? Oh, yeah, my mom, the babies are going to be Chinese. Well, why do you say that? Because in social studies class, we learned that 2 out of 3 children born are Chinese. And I'm not, so they're going to be Chinese. Anyway, that was pretty bad. I'm sorry. Didn't mean to offend anybody there. So the next one's going to be 11 squared, 12 squared, 13 squared, 14 squared, 15 squared, 16 squared, 17 squared, 18 squared, 19 squared, and 20 squared. These ones, I'll bet there's maybe 3 or 4 people in the class that could name most of them. I do expect you to have these memorized. You got them? We got 121, 144, and then it's 1 something. 1, yep, you said it, I didn't. And then 196, and then that road in Paris Township that goes up and down and around by West Branch. 225. If you've ever bought computer memory, you've probably seen this number. 256. Ever see that number when you're buying computer stuff? Everything in computers is a power of 2. Yep. Any Mustang aficionados? When the Mustang first came out, this was the cubic inch displacement they put in it. They put a 289 V8 in the Mustangs. 18 squared is 324. 19 squared is 361. That one always gets me. I think it's 381. It's not. It's 361. And of course, 20 squared is 400. So the deal is, each one of those numbers is what we call in mathematics a perfect square. And I don't ask you to memorize them because I don't want to ruin your day. I don't want to ruin your week. I don't want to make you look bad because you can't memorize 10 things or 20 things. If you don't know these, you're going to struggle with factoring what we're factoring today. But if you do, it's going to be a piece of cake. It's going to be real easy. Tonight's homework is going to take you 6 minutes or less. It's super easy. All you got to do is follow a couple of patterns. So the cool thing about this difference of 2 squares is we go from 2 terms to 4. We go from 2 to 4. Notice the way that triangle is. It goes from a couple of things to more. So it's going to end up going to 4 terms. We're going to have parenthesis, 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 parenthesis. And one of them is going to be a plus and one of them is going to be a minus. And what's weird is to go from the first, what we start with, to what we end up with, we're just taking square roots. So you got to think to yourself, what's the square root of a squared? The square root of a squared is a, and that's what's going to go in this first slot. And then you got to ask yourself, what's the square root of b squared? And the square root of b squared is b, so that's what's going to go on the other slide. Okay. So that's called a difference of 2 squares. Do you want to see an example of that now, or do you want to finish the notes and then do examples? Finish the notes and then look at examples. All right, here we go. The next one is how I like to get people's attention. It's kind of rude. You know that. Millennials are easily offended. I'm sorry. I know I've offended most of you in here this year already. And if I haven't yet, I will. Not on purpose. Psst. 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 Get off your cell phone. Psst. Hey, look. P stands for perfect. There's something special about these. That's why this section's called special cases. Now, the S in difference of 2 squares was for squares, and the S in this is also for squares. Square, perfect square. Now trinomial, trinomial. So we're starting with 3, and we're going to end up with 2. Here we're starting with 3, and we're going to end up with 2. We're starting with 3 terms. The first term is a squared. The last term is b squared. So again, what's going to happen is you're going to have a perfect square at the beginning. You're going to have a perfect square on the end. What's so special about this is the middle term. The middle term is probably more important than what the first and the last terms are. This middle term ends up being twice the square root of the first term times the square root of the last term. I'll say that again. The middle term is twice the square root of the first term times the square root of the last term. So let's think about that. Twice times this. What's the square root of a squared? A. And what's the square root of b? B. So the middle term has to be 2 times a times b. If it's not, then you don't have one of these and you can't follow this pattern. And that's going to come up in chapter 5 again. So let me fill in some signs. The b squared is always going to be added. That's always, always, always going to be plus. Now, for sake of saving time, space, and energy, there are two different perfect square trinomials that you might see. Sometimes it's a plus, and if it's a plus up there, it's going to be a plus down here. If it's a minus up there, it's going to be a minus down here. Now, when we found our factoring for a difference of two squares, we had to take square roots. Same thing here. What's the square root of a squared? A. We're just going to drop an a right in here. What's the square root of b squared? B, and we're going to drop a b right in here. These should be really easy. These should be really easy. All you got to do is just follow the pattern, and they fall into place. It's out just like that, really fast. The question is, will you be able to recognize one of these? Will you be able to spot one? Will you be able to tell if you have a perfect square trinomial? So let's look at some examples. We ready? Question. Oh, thank you. Good looking out. I forgot the square. And thank you for pointing that out. So I'm so glad that somebody pointed that out, because I almost did this to you. That's that's binomial. That's binomial square. A binomial squared, right? Or the square of a binomial. So a perfect square trinomial is going to become a binomial squared. I can't believe I almost forgot the two. I'm going to neck myself. I'm going to try it again. That's going to come through on the video. Okay. I think I just broke my C2 on my L1. All right, here we go. Example 1, factor the special case. Factor the special case. Let's go with x squared minus 25. So we got to ask ourselves, is this the difference of two squares, or is this a perfect square trinomial? It's a difference of two squares? DOTS, so it's not a perfect square trinomial. So we're going to follow the pattern for a difference of two squares. So let's look back at that. So we start with 2, and we're going to end up with two binomials. So our answer is going to go bam, 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 bam. Okay. Remember the whole triangle thing that I had going on before? Is that a nice visual? Does that help any at all? I think it's pretty cool. So let's look at the pattern. There's a plus and a minus in those. There's always going to be a plus or a minus in those. Plus, minus. Now all we got to do, we started with a squared, we got to go to a. We started with b squared, got to go to b. So we're just taking square roots. That's all we're doing. We got to take the square root of x squared, and that's what's going to get dropped in right there and right there. So it's going to be what? X. All right. And then we just got to take the square root of 25, and that's going to get dropped in the other spots. 5. That's it. Whoa, let me make it blue. What do you think of those? The thing is, you got to be able to recognize them. So far, so good. Good. All right, example 2. Factor the special case. X to the squared minus 12x plus 36. So we got to ask ourselves, they're telling us it's a special case, so we just got to figure out which one it is. Is this a difference of two squares, or is this a psst? I'm hearing psst. Yeah, it's a psst. So a psst. If we look at the psst, that's that other triangle. So we start with 3, end up with 2. So this is going to be that upside down triangle thing. All right, so I'm going to take this. It's Friday. Everybody knows what's up. We're going to flip it over. Okay. That's a little crooked. That's better. So we're going to end up with 2 squared. And again, we're just taking square roots. We got to take the square root of the first term, and that's going to go right there. So what's that going to be? An x. And again, we're just taking square roots. It's that easy. That's why you got to know these squares. The square root of 36, and that's going to get dropped off right there. That's going to be a 6. Now, whatever sign we have in the middle, that's what's going to be the sign in the middle. It's going to be a minus. Like a bows. Those are easy. You can do those in 6 seconds, can't you? If you know what a perfect square is. So you know your perfect squares. Are there any questions, comments, concerns, short or long debate so far? Okay. Example 3. Factor the special case 4x squared minus 49. So this is the dots. Dots. So we're going to have binomial, 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 plus or minus square root of the first term. 2, we do better, 2x, so that's a 2x and 2x, and then the square root of the last term. 7 and 7, and that's it. Word to the wise. I know some people really like shortcuts. Some people like shorthand. I like shortcuts. I like shorthand. Please don't do this. Please don't write it as 2x plus or minus 7. I understand what you're trying to say, but please, for the sake of what's good and right and decent in math, don't write it like that, okay? Don't write it like that. Please don't. Okay? Make sure you write it out as the product of 2 binomials, 1's plus, 1's minus. Everybody good there? Okay, we got 2 more examples and we're done. Example 4, sorry. Example 4, factor completely. Factor completely. X to the 4th power minus 81. 81, sorry, didn't mean to go to Spanglish there for you. I have a problem with the directions. Normally, there's just one direction, factor. Now the directions say factor completely. That means, you know, you're probably going to factor and you think you're done. But there's going to be probably a little bit more that you have to do to be done. So does anybody know what the prefix pseudo means? Pseudo means not genuine or fake. Does anybody know what the word quasi, the prefix quasi means? It means similar. It has a similar meaning. So anyways, these are what we call pseudo or quasi-quadratic. How do you like that? Pseudo-quadratic or quasi-quadratic. They're not quadratic, but they're similar to being quadratic. Now, I know we have some of you that are very good at history. Anybody know what the Germans did in World War II that made their Navy better than our Navy? They used U-boats. They used U-boats. So I'm going to let U equal x squared. This is going to seem weird. You don't have to do it this way, but I'm introducing this technique. This is a magic trick that math people like to use. When you get to advanced math, you're going to find that college professors, they won't tell you these tricks. They just use them, and they expect that you know them. Where do you learn them? Well, if your Algebra 2 teacher doesn't show you, then you don't. So if U equals x squared, then U squared would equal x squared squared. X squared squared, which is x to the 4th. You see what I got going on there? Okay, so now what I'm going to do is I'm going to use little Mrs. Fisher. I'm going to use some substitution. I'm going to use substitution. So instead of x to the 4th, it's going to be U squared minus 81. Oh, now it is quadratic. Now it's not just pseudo-quadratic or quasi-quadratic. Now it's quadratic, and I know how to factor now. So this is a difference of 2 squares. So it's going to be something plus and something minus, right? What are we going to have? U minus 9 and U plus 9, right? But wait just a minute. What is U? U is x squared, so we're going to substitute back again. We got to back substitute. So that's x squared plus 9 and x squared minus 9. Now, I know that some of you are very intelligent and capable beings and could probably just go straight from what we started with straight down to what we ended up with there, right? I don't have a problem with that. I just wanted to show you the U substitution. It's effective. There's some problems where you really need to use it. No pun intended, where you really need to use it. Anyway, look at the directions. The directions didn't just have one, they had two directions. It says factor completely. Are we done? No. Remember earlier I said, would you be able to recognize one of these special cases? Would you be able to recognize two of these special cases? Because we have one left, don't we? This is also a dot. So this x squared plus 9 is just going to be followed through, but then we have another difference of two squares, don't we? So what's this x squared minus 9? What's that going to become? X plus 3 and x minus 3. I'm telling you right now, on the next quiz, there's going to be a problem like this. Everybody misses it because they can't spot that second difference of two squares. What do you think? You going to be able to find it? Going to be able to spot it? I feel pretty good about these so far. I feel really good about these so far. One example to go. You ready for it? Uno más, por favor. Example 5. Factor completely negative 3x squared minus 36x minus, again, I can't multiply that big number in my head. Shame on me. It's okay. I'm going to cheat a little bit. Sorry about the delay game. I'd like to give a shout out to everybody that wore red today. Red's a good color. I didn't wear red. Oh shoot, I just multiplied that out. I forgot what it is. I think I got it. Okay. All right, we're ready? This example is so great. It's got so many awesome parts to it. You look at that and you're like, well, it's not a special case. It can be. Now, we got a negative 3 in the first term. The second term, 36, is divisible by 3, isn't it? 4 plus 3 is 7 plus 2 is 9. 9 is divisible by 3. So we could factor a 3 out of this, couldn't we? Okay. So let's factor. Let's actually, remember math people don't like leading negatives also? So let's factor out a negative 3. So what's that going to leave behind? That's going to make positive x squared. That's going to make plus, that could be 12x. Okay. Now on the end, I got to do this the old-fashioned way. How many times does 3 go into 4? 32. 3 goes into 4 once. Is it 143? Let's see. That's a 1. That's a 3. That's a 4. Is it 144? Oh! Awesome. That's so cool. So here's the question you got to ask yourself. Can I spot a difference of two squares? Can I spot a perfect square trinomial? Is that trinomial a perfect square trinomial? Slow your roll. Slow your roll. Slow your roll. What's this middle term got to be? What did we say? We said it's got to be 2 times the square root of the first term times the square root of the last term. Right? Let's see. Square root of x squared is x. 2 times x. So far, so good. What's the square root of 144? 12. So 2 times x times 12 is 24x. Is that middle term the right kind of term? So is it a perfect square trinomial? It looks like it, but it's not. Oh, so sometimes that factor completely. Sometimes you might only be able to factor out a GCF. You picking up what I'm putting down? Questions? Comments? Well, that's it. It's been real. It's been fun. Anybody want to give a shout out to anybody? Noah Hoffman? Okay. Noah Hoffman gets a shout out. Cool beans. Well, I'll see you next time on YouTube channel. Good.